Name that triangle. You will learn how to identify triangles using the Pythagorean theorem. When looking at the Pythagorean theorem, a squared plus b squared is equal to c squared, which is this second one. That theorem is used to find the length sides of a right triangle. But we can also determine whether a triangle is acute or obtuse using that same theorem. But this time, when you compare the side squares and the sum, we want to end up with it being less than to be acute and greater than to be obtuse. So if you look at the first one, we see that the longer side is C. It's going to be C. You're going to take C and you're going to square it. Take the two shorter sides, A and B, and you're going to square them and then add those squares together. If C squared is less than A squared plus B squared, then the triangle is an acute triangle. Now we want to do the same thing for the second triangle, which is going to be a right triangle. C is still going to be the longer side. So we take the longer side, substitute it back in the place of C and square it. The two shorter sides, which are A and B, substitute them back in the place of A and B and square them. Add the squares together. But this time, if they're equal, then it is a right triangle. The last one, we still have C. C is going to be the longer side. You're going to take C, whatever that number is, put it back in the place of C and square it. The two shorter sides are going to be A and B. Substitute those back in the place of A and B and square them and add the squares together. And if the square of C, the longer side, is greater than the sum of the two shorter sides squared, then the triangle is obtuse. So you really want to pay close attention to these three ways to classify triangles. Now looking at the first one, here we see the longer side is 20. And we want to figure out, is this triangle a right triangle? So you're going to substitute 20 back in the place of C and square it. Substitute 12 back in the place of A and square it. Substitute 16 back in the place of B and square it. Once you square those two numbers, add them together, and we want to know, is it equal to? That's the question we want to answer. 20 squared is 400. 12 squared is 144. I'm going to add that to 16 squared, which is 256. 144 plus 256 is 400. And since 400 is the same as the other side, they're equal, then this is a right triangle. To determine if a triangle is acute, you do the same thing. Figure out which side is the longest side. The longest side, which is C, is the square root of 35. So I'm going to substitute that back in the place of C and square it. I want to know, is it equal to 5 squared plus 4 squared? Square root of 35 times square root of 35 is 35 itself. 5 times 5 is 25. 4 times 4 is 16. Add those two numbers together, you end up with 41. And now we're going to compare 35 to 41. And since 35 is less than 41, this is an acute triangle. Now let's do the same thing for this triangle with side lengths 8, 12, and 15. 15 is the longest side. So we're going to take 15, substitute it back in the place of C and square it. So that's 15 squared. Is it equal to a squared, which is 8 plus 12 squared. 15 squared is 225. 8 squared is 64, and 12 squared is 144. I'm going to add 64 to 144, and we'll end up with 208. Now we want to compare 225 to 208. And since 225 is greater than 208, this is an obtuse triangle. Now we have a triangle that has side lengths of 5, 6, and 8. The longer side is 8, excuse me. So we're going to take 8, put it back in the place of C and square it. So that's 8 squared. And we want to know, is it equal to, greater than, or less than? I'm just going to put that in there. So we're going to take 5 and square it and add that to 6 squared. 8 squared is 64. 5 squared is 25, and 36 is 6 squared. Add 36 to 25, you get 61. We want to compare 64 to 61. I said 64 is greater than 61. This is an obtuse triangle. Now we're going to look at 2 more, and hopefully by then you'll have it. The longest side is 7. So we're going to take 7 and we're going to square it. Take 4, square it, and then add that to 6 squared. We want to compare them at the end. 7 squared is 49. 4 squared is 16. 6 squared is 36. Add those 2 squares together, I get 52. And now I want to compare 49 to 52. 49 is less than 52, so this is an acute triangle. And then this last one, same thing. The longest side is 37. So we're going to take 37 and square it. We want to compare that to 12 squared plus 35 squared. 37 squared is 1,369. 12 squared is 144. We want to add that to 35 squared, which is 1225. If I add those two together, I'll get 1369, which is the same as the other side. And since they're equal, this is a right triangle. So this concludes the lesson. Please go back and look at this as many times as possible, and then go and try the questions or the problems that are in teams. If you have any questions, please give me a call at 407-852-8568, and have a good day.